last week we have learned about the design criteria based on three, by space and by energy requirement, and the one is by budget. But this time we are going to do the inverter and PV array matching. Okay, so there's inverter, we call that grid inverter. The grid inverter has their own input voltage, and the PV array also, we have the output voltage, or we have the maximum voltage, maximum power point voltage, or opposite voltage, something like that. So this voltage, we are going to do the match. We're going to do the matching between these two equipments. Okay, because it's important to ensure that the array is matched to the inverter input. Point there. Important to ensure the array is matched to the input. Inverter input. Very important. We have to make sure the inverter input, okay, they have the limit, they have the range. We have to make sure that the output voltage from the PV array tu, the cable, the output voltage from the PV array to the input of the inverter match. Maksudnya tak boleh oversize, tak boleh too big or too small lah the values. If too small, maybe it's not, you cannot turn on the inverter. That's why very important. Okay, the match of the voltage between these two equipments. So inverter should be chosen so that the maximum power output from the design PV array matches the inverter's maximum array power input. Okay, design PV array given in web means that maximum power output match the inverter maximum array power input. Okay. Then avoid oversizing. Okay, we want to avoid oversizing of the inverter. And then the designer needs to ensure that the inverter and PV array match in terms of voltage, current, and power to ensure a safe and efficient PV system. So matching voltage specification. Calculate the expected voltage output of the array that is affected by the change of cell temperatures. Tak jumpa benda ni mana? Hilang dah. Okay. So we have to calculate the expected voltage output of the array. Okay. From the output voltage, from the maximum voltage from the PV array or PV module, we need to calculate it based on the F10, the cell temperature that affected by the cell temperatures. So kita can consider the calculation must be considered based on these factors. Okay. That's how we do the calculation. But it's okay. After that, we're going to go for the equation. And then datasheet generally provide at least one temperature coefficient for voltage specific rating that describes the effect of temperature on the cell voltage. Okay. So at least temperature coefficient lah. Dia akan ada VOC. Dan dia ada juga power. Power ni PMP. PMP ni nanti boleh pakai untuk VMP. Tapi tak apa. Okay, nanti saya detail. Usually expressed as a percentage or involved per degree Celsius, whereas some manufacturers only provide a Pmax temperature coefficient that can be used as an approximation for the voltage temperature coefficient. So in order to calculate the expected voltage, sebelum ni kita tak apa usik sangat. Kali ni kita akan terus menerus. We are going to touch about the temperature coefficient, power and the voltage. We are going to play with that. Okay. This time we are going to focus on that. Okay. So dia cerita pasal temperature coefficient dia lah. So yang so dekat sini adalah output voltage contohnya yang kita akan guna is VOC. So the VOC, for the case of VOC tu kita akan guna temperature coefficient of VOC for example. And then PMP, the BMP. So BMP tu kita akan guna PMP punya temperature coefficient. Kita boleh guna if the VMP is not given. Okay. Kita hadam dulu. Okay, hadam dulu. Okay. So, first, what should we do? Okay, first, what should we do? We are going to focus first in the module. Module part. The solar module. Like I told you, for in this subtopic, we are going to do the match, the voltage matching between the modules or PV arrays and the inverter. Okay, dua ni. We need to calculate based on the expected based on the temperature coefficient. But first of all, I'm going first for the module part. So this is module part, okay? Not the inverter yet. The inverter after this. First we focus on the modules or PV array. Okay, this one here. Calculate. Pergi bawah. Buat lagi. Okay. Calculating maximum voltage. Okay. Ni. Okay, based on VOC ya. Okay. The module's maximum voltage. Module maximum voltage, I think we know already. VOC ya. Yes, we have VMP. But actually, the maximum voltage that achieved by the module is the VOC ya. Because the VOC must be higher than the VMP. That's normal. Okay, logic. That's standard. It's present at the minimum cell temperature, which in this case is 20 degrees C. Okay. Module maximum voltage nearly to VOC is present at the minimum cell temperature. Faham tak maksudnya? Minimum cell temperature 20 degree. Do you understand what is the meaning of this? Maximum voltage of the modules present or achieve where the cell temperature is the minimum one. Boleh tak siapa? Saya nak ketik, tak ada nama ni. Nafis. Ada Nafis dalam ni?
Ada sir.
Kenapa? Faham tak statement ni? Maximum voltage of the module tu, dia achieve where the cell temperature tu minimum. The minimum one, not the maximum one. Faham tak? Setuju tak? Kau faham tak? Kau tak faham apa?
Tengah memahami lagi.
Tengah memahami. If you still remember, before this, okay, the performance of PV module atau PV panel abang panggil kan. Okay, PV module tu will depend on two factors. One is the solar irradiance. Ingat kan? Solar irradiance. If the solar irradiance higher, so the current will be higher while the voltage slightly increase. Okay. Second factor is the temperature. Temperature is the inverse way. I mean in the opposite way. If the temperature getting higher, the voltage, the output voltage will degrade. Okay lah, current slightly increase, but the voltage itself, they will significantly decrease. Once the voltage is decreased, then the power itself will decrease also lah. Mean that dia akan degrade lah, performance dia akan turun, drop. So this is the thing. Temperature getting higher, worst case. Modul tu kira worst case lah. But temperature of the module tu rendah, lower, like in the winter ke, in the spring ke, yang temperature the lower, perform lebih better for the module. And the module perform better. This is the meaning. So module maximum voltage tu. Module will achieve the higher voltage when the temperature is the minimum one. That's why in this case 20 degrees C. Boleh Nafis?
Boleh sir, boleh.
Faham kan? Faham kan? When the degree is 20 degrees C, for example, in the Genting Highland, Genting Resort World, yang Genting World yang atas tu boleh pergi 15 degrees C. So saya rasa ambientnya 15 boleh turun. So mungkin temperature tu ada effect, tapi mungkin that's better lah. I mean they perform better. What we call that? Silicon punya karakteristik tu, dia kalau suhu rendah dia lebih perform better kan. But kalau ada fogging tu cerita lain lah. For awan tu cerita lain. Itu dia block pula irradiance. Tapi kalau dari segi suhu, in term of temperature, Genting Highland performs expectation module if sunny days without cloud, without fog, in the module can perform better in the Genting Highland instead of Pekan or Gambang. Faham kan? Sebab Gambang tu dekat ground, tak berapa
Faham,
sejuk, 30 lebih. Jadi itu perform dia lebih lemau daripada yang dekat genting tu. Kalau cuaca cerah, tidak ada no cloud, no fog itu maksud dia. That's why we call that as the maximum voltage. Kita tak panggil minimum voltage. Suhu minimum, temperature is minimum, but the voltage is maximum here. Okay. So, okay. Then important to use proper circuit voltage and adjust this figure according to the temperature coefficient when calculating the maximum voltage. Okay. So apa kita kena buat? We need to calculate lah. We need to calculate the V max. I call that as the mana ya? Tak jumpa lagi. V max OC. Okay. V max OC. When the value is given in percentage lah. This one is for the percentage case lah. So inilah dia. VOC STC multiply with 1 plus temperature coefficient of the VOC. Yang ni ambil VOC punya. Okay. Ada. Kalau tadi tengok tadi, ni ada kan? Ni ada mana tadi? Ni. So ambil ni kan. For example, negative 80 over 1000 sebab millivolt kan. So this is the value of temperature coefficient of VOC. Masuk nilai tu. Okay, maksudnya ni. Okay, satu tu. And then T cell minimum. T cell minimum here how much? Siapa aku nak petik nama? Fatin Kristina.
Yes, sir.
T cell minimum dekat sini how much? Okay. TSTC berapa?
25.
25. T cell minimum?
20 ke?
20. Janganlah 20 K.
Okay.
20. Jawapan dia 20. Jangan takut walaupun dia 20 minus 25. Don't be afraid. Okay. Okay. So T cell minimum here is 20. Ya, saya tulis atas ni. Ini kat atas ni saja tanya balik. 20 why? This the value of the expected value, okay, expected or the ideal value of the temperature, cell temperature when the module will perform the better one. Macam tu. So ini 20. Dia akan jadi 20 tolak 25 minus 5. Oh my god, what happened? Don't worry don't worry because the VOC is 7. VOC 7 ni plus tak ingat minus okay, minus kot sini tak ingat dah
minus negatif
T cell minus TSTC, so this one also become minus, so minus and minus with become plus lah, so dia akan tambah, so logiknya nanti at the end dia akan lebih besar daripada VOC STC. Ke pelik cara penilaian aku ni. Boleh? Maksudnya maksimum voltage ketika ini dia sepatutnya lebih tinggi daripada nilai original ni. Ni. Alamak, mana ni? Tak jumpa. Tak jumpa pen ni. Okey. Ni. Logik lah. Maximum voltage. Okay. Must be better than VOC lah. Dia akan tinggi lagi lah. Sebenarnya tadi 20 minus 25 dia akan jadi negatif. And this one also negative. Then negative plus 1 plus something. So if for example the VOC is 20, maybe 21.5. The higher, the value will become higher than the original VOC STC. Okay. That one for the case of percentage. For the case of absolute value, sebelum ni pun dah buat kan, test kan. So VOC STC plus sajalah. Okay, terus ke arah ni. Still the same, 20 minus 25. Okay, 20 minus 25. Okay. This is for the case of the maximum voltage versus one ataupun VOC base. Okay, VOC base. Kenapa saya cakap tu? Sebab ada satu lagi. Okay. We have another one. Calculating maximum voltage. So kiranya for the case of modules, you kena kira yang ni yang pertama. Ya, tak jumpa aku jumpa mana pun ni. Mana dia? Situ pula. Main apa ni? Jadi dapat. Okay. So this is the first. Second case. number 2. Calculating the maximum voltage VMP base. This time is VMP. Okay, just now it's VOC, now it's VMP. Okay, don't get confused, not get confused. Don't get cuak lagi sebab kita go one by one lah. Jangan takut yang belakang-belakang tu. So insyaAllah. Okay, module maximum voltage VMP is present at the minimum cell temperature, which in this case of 20 degrees C. Okay, sama, ini case dia sama, minimum cell temperature 20 degree, but this time we use VMP. Okay, VMP this time. This time for the case of VMP. First case tadi VOC, now VMP. Okay, 20 degree C. Therefore, important to use blah blah blah. Okay, and then given in percentage. Okay, almost the same. The different only max. Okay, max MP, and this one is VMP. Okay, and then T cell minimum also remain the same, 20, and TSTC is 25. Okay, 25. While for the case of absolute value, sama juga, plus, dan ini adalah gamma untuk VMP, T cell minus TSC still same, 20 minus 25. Okay. So, ini tahu just now, because VOC, okay, mana dah? Okay. Just now, VOC. But this time, kita guna VMP. Means, we need to have the temperature coefficient of VMP. Okay, just now we use VOC. Now we need to have the value of VMP lah. Okay. Okay, alright. Okay. Tak apa, saya explain sekejap lagi. Okay, let's say we don't have the temperature coefficient for VMP. Sebab kalau you tengok tadi contohnya, yang ni tak bagi tau. Yang ni dia bagi power, which is power adalah PMP. Lepas tu dia bagi VOC, bukan VMP. So here, no VMP. So, how? What should you do? Okay? Okay, kita pause sekejap. Okay? Maksudnya, tak apa. Macam mana kita nak buat tu, saya letak tepi dulu. Boleh So, saya ingat sekarang, tinggal satu persoalan. What should we do when the gamma VMP is not given, or the temperature coefficient of VMP is not given in the datasheet? So, itu nanti. Okay. Saya lompat jap. Okay, saya lompat yang third part. Saya tinggal tadi as the persoalan, question. Okay, sekarang saya pergi ke yang ketiga. Ayah. Ini memang yang betul ni. Okay, the third one is to calculate the minimum voltage. Calculating the minimum voltage. Just now, first case, second case, we calculate the maximum voltage. This time, we are going to calculate the minimum voltage. Okay. For this case, is the opposite to the first and the second one. Okay. Where the module's minimum voltage. Okay. Module's minimum voltage will occur when the cell hits the hottest one. Hottest. At a set temperature of 75 degrees C. Why must 75 degrees C? Trust me, we just follow from the SEDA or the KETA. So they decide for us. Maybe maximum voltage, cell temperature voltage recorded in nature in the typical case is 75 degrees C. That's why they put 75 degrees C. Itu bukan ketetapan saya. It's not from me, but it's from the SEDA itself. They use 75 degrees C. Don't ask me why they don't use 80 or 70. So they just fix 75. Means maybe the highest cell temperature ever recorded in nature, most case 75 maybe. In Negeri Sembilan for example, in Jelebu for example. So kita follow je lah. Follow je lah. Okay. Just now, maximum voltage at the minimum cell temperature of 20 degrees C. That's also the same. 20 degrees C also decided by the SEDA. So we just follow it. Don't argue. Okay. 20 minimum, 75 degree C is the maximum voltage for the cell temperature. Okay, so we just follow. Okay, so this is calculated using the maximum power voltage BMP and the corresponding temperature coefficient. Okay, this time mean, just now max. Sudah max. Tadi max. Sekarang kita sudah tukarlah V min. Okay. VMP still remain the same because we are using the the VMP one, so, VMP STC, and then again this comes the temperature coefficient for the VMP. Here T cell max. Okay, T cell max berapa? Siapa kau tanya? Aku tak nampak. Khalis.
Ya, so.
T cell max berapa dekat sini?
75.
Berapa? Ulang balik.
75.
Yes, correct. 75. TSTC
25.
25. Pandai. Ya, tak tidur lah, bagus Fokus Okay,
Ya, biasa.
Right. Okay, so T-cell max here is 75 minus 25. Okay, 75 minus 25, apparently dia akan become positive lah. Value become positive. And this one is negative. Right, negative. Negative and positive become negative, means that it will become minus. When become minus means it will degrade. So secara logiknya dia lebih kecil, lebih kecil, lesser than the VMP STC lah. In your calculation must be lower than the VMP STC. It should be. It must be. Kalau you kira dapat positif, maka you salah. Totally salah. Okay. So dapat tadi kan? Okay. Untuk kes ni absolute value sama juga, tapi tulis juga, takut lupa. Ini plus. Tak ada one plus So terus prosednya ini. Okay. So first cases maximum voltage based on the VOC. Second case maximum voltage based on VMP. Third case minimum voltage based on the VMP juga. Okay. We return back to the question. What will happen if the temperature coefficient for the VMP is not given? What should we do? This is the answer. Okay. If the temperature coefficient for maximum power voltage, okay, if alpha, okay, gamma VMP is not given, what should we do? So we are going to use temperature coefficient for maximum power ataupun PMP. Boleh. But in one condition, in the unit of percentage lah, should be used. Maksudnya, same case with this data sheet, okay? Okay, data sheet here it's not given you, they doesn't give, okay, doesn't give you the power, doesn't give you the VMP, only give PMP. And this is apparently in percentage. So we can just use minus 0.5, just like that. Okay, because the given value is in the power, percentage. It presents in percentage, so ambil terus, tanpa ragu-ragu. When the VMP is not given. Okay. Because I told you VMP tu memang totally correlate directly to the PMP lah. So, okay. In the unit, in percentage should be used. In case the gamma PMP is not given, then use VOC. Okay. Kalau tak ada, sebab ada, there's some data sheet who only give you the ISC and VOC for the temperature coefficient case. There's some modules like that. So at the time, we just take the VOC lah. So mean the worst cases tu teruk sangat, gunalah VOC. But the chronology first, you need to find for the okay. First looking for the gamma VMP. If not given, go for the PMP. If it's not given, then finally go for the VOC. Okay, go for the VOC. Okay. This PMP, okay, this PMP must be in degrees. Percentage, sorry. What will happen? if the gamma PMP value is given in watt, sebab power, so give in watt or milliwatt, we must convert it to percentage. Okay, kita kena convert to percentage lah. Kita convert ni. Once kita dah ada dalam watt tu, awak boleh convert je lah kepada percentage. How to convert it? Very easy. Very easy. Ni dia. PMP, gamma PMP over PMP, gamma temperature coefficient over PMP multiply with 100. Okay, multiply with 100 because watt over watt, kita bagi dengan watt. Bagi watt, dan kita akan dapat persen lah, dalam 100 dapat persen. That's why you kena bagi dengan PMP tu untuk percentage. Sebab apa? If you use the percentage, you still can use, actually you can still use in the absolute value. Okay, absolute value boleh guna. Tapi absolute value tu sebab dia macam mana pun kalau you guna, kalau if they give you the PMP kan, I mean if they give you this value in watt and in watt, so at the end you kena tukar dulu pada VMP kan, kalau you nak tukar jadi voltage kan payah. So senang ni, tukar pada percentage. So we use only percentage to calculate. Okay, if the value is given in, remember if the value is given is absolute number, then you change it to the percentage. Cara dia macam ni. Simple. Okay.
Saya nak tanya, kalau gamma VOC tu dia bagi dalam bukan persen, kena tukar persen juga ah?
Ya, nanti tu. Contoh, tak boleh pakai, boleh pakai. Sebab dia voltage. Okay, let's say awak cari VMP tak ada, cari PMP pun tak ada VOC dalam voltage, tak ada masalah. Boleh je. Terus guna VOC dalam unit. Maksudnya dalam absolute value lah, dalam unit volt. Boleh, sebab dia voltage dengan voltage tak ada masalah kan. Voltage kita pakailah equation absolute tu.
Oh, kalau voltage tak payah ni lah, convert lah.
Sebab dia voltage kan.
Oh, okay. Faham.
Itu dah settle dah. Ini pandai bagan ni rasa. Okay, sebab kita bagi equation ni kan. So voltage dengan voltage tak masalah. Dia isu sekarang PMP tu watt. Mana boleh sekali. Kau tak boleh guna watt dalam ni lah. Tu macam mana nak buat? Tukar dulu percentage. Dan terus guna equation yang atas ni. Kita guna yang atas ni. So ni tak ada isu lah sebab dia percentage. Bawah tu tak boleh. Tak boleh masuknya PMP yang watt tu dalam ni. Sebab tak kena unit kan, unit lain. Sebab dia absolute. Begitu. Any other question? Boleh tanya. Faham? Siapa nak petik nama? Dah susah lah satu skrin. Kalau dua skrin ni sedap je berceduk. Yang mana ingat je lah ni. Siapa lah? Atikan Nordin. Okay.
Ya, okey sir. Faham.
Bagus Intat Cik Intat. Siapa lagi Ivan.
Okay, sir.
No question Understand
Okay. Yes, understand.
Okay.
Jawab.
Okay. Itu yang untuk bahagian voltage lah. Okay, bahagian voltage for the PV module. Okay, PV module side. Okay, we move forward. Boleh Okay. Now let's go to the inverters part. Okay, inverters part lah. So inverters input voltage. What is the inverter input voltage? Okay, this is for me, it's very super critical for the person who will start, for example, later on after this, after you graduate, then you plan to do in the solar company kan. Nanti you keep playing with this kind of things, this kind of data sheet. Okay, so even though you already taking the alternative energy, if you don't know about this, so for me agak mengecewakan lah, so disappointed lah kalau you tak tahu apa-apa ni. Nanti orang tanya you tak boleh nak respon sesuatu benda yang sangat bagi saya kurang sikit lah. Okay, so inverters input voltage. So ini just the example of some old school type of the inverter. Okay, inverter for the grid inverter Fronius. Okay, Fronius. Now recently, I think you heard already, for those who have gone to the industrial training in the place of the construction of solar pump, for example, maybe they know already and they get used with this kind of things. Huawei kan, brand Huawei, saya pun dah mention sebelum ni, so brand Huawei tu agak sekarang ni sangat meletup-letup, sangat digunakan secara luas. Okay, not only for phone, not only for the laptop, inverter pun dia ambil the market. This I have to be honest, memang seriously, and it's a Chinese company which can beat the international one. They have very good reputation and very good performance also. Okay, but we still, for the example, for the sake of the example in this study, kita pakai Fronius lah, old school. Okay. Ini data sheet for the inverter. So the important is the input voltage, but the several values also. So first one, inverter input voltage. How can we trace that? Usually they write in the mana di situ lagi? Di sini Siapa tengok saya tadi? Okay, MPP voltage range ataupun inverter input voltage, whatever lah. The clue is you are going to see the range of voltage here. Dia ada range. Okay, ada range. From what 100 to what 100. Itu is very easy way to track, to trace the MPP voltage. If they right, of course, no problem lah. MPP voltage ke, inverter input voltage ke. So this is how we trigger. We have to try. We have to find for this. Okay. So there the minimum. So the minimum one we call it as the inverter's minimum window voltage. Panggil sebagai window voltage. But it's okay lah kalau dia kata minimum MPP voltage ke whatever lah. Tapi this one is the minimum window voltage lah. Okay, kita write as the Vmax max to maximum window inverter. Vmax window inverter. Okay. While the highest one here, 420, 210 until 420. So that 420 is the inverter maximum window voltage, which is called as the Vmax max inverter. Ini salah. Ini salah. Ini minimum, sorry. Minimum window inverter, and this one is a maximum lah, maximum. Okay. Then after that usually you are going to see another input voltage, a maximum, another value of the maximum one. So that maximum one called as the maximum input voltage. It should be, most of the cases it will be higher than this. Nampak tak? Dia besar sikit. 530. No doubt, there's some inverter also 800 and 800. Ada juga macam tu. Maksudnya, for example, this one 420, dia ada juga 420 juga. At the time tu memang tak boleh buat apa, memang 420 juga lah. You kira based on the 420. But most cases, if there are 850 for example, the next maximum input voltage, we call that as the inverter's maximum voltage only. No window. Okay, no window. So this called usually the higher lah. If 150 then 1000. Itulah biasanya kebiasaannya. Okay. But for this case we call that as the Vmax inverter only lah. So kita ada tiga nilai kat sini. The critical one is the both upper one, the range one, which is the inverter minimum window voltage and the inverter's maximum window voltage. Then the other one is the maximum inverter voltage tadi, inverter's maximum voltage. Okay, Vmax inverter. So ni ada tiga tempat. I'm not going to touch about the current yet. Itu nanti. Sekarang kita cerita pasal voltage dulu. We focus on the voltage. Okay, we focus on the voltage. Okay. Why this voltage is important? Why after we know the maximum voltage of the inverter originally, so we need to do some calculation. The calculation that we are going to do is we call that as the calculating minimum number of modules in string. Kenapa voltage tu kita penting? Kenapa kita pentingkan okay, minimum number of modules in string? we want to calculate the minimum number of modules in a string. In a string. Satu string tu, one string. How many modules? Okay. One string, how many modules? Okay. There's three part here. Okay, there's three part here. Okay. Let's go for the second one. Boleh, kita pergi yang second. Okay. I know. Okay. Okay, kita buat sekejap. Boleh. The minimum inverter input voltage should be multiplied by 1.1 to account for the 10% safety margin required. Maksudnya apa? Tadi kita dah tahu dah inverter punya minimum dengan maksimum. Lepas tu lagi maksimum. Kita dah tahu dah value dia berapa. Tapi untuk kira minimum number of modules in a string, okay, minimum number of modules in string ni, we need to consider some margin. Kita tak boleh ambil exactly 210 volt, for example, just now 210 volt kan, 10 volt kan. So you cannot, in this calculation, we cannot use 210. We must have some margin to back up if something happen to the modules, degrade some instantaneously due to the sudden emergence of the cloud, for example. So kena ada backup. So we have to put some margin there. How much is the margin? It's the 10% margin. What does it mean? We are going to have another term. Kita panggil sebagai minimum window inverter allow ataupun allowable minimum window inverter voltage. Macam tu. Whatever. Okay. Originally, okay, kalau saya kaitkan dengan tadi Vmin with inverter tu berapa? 210 kan? 210 volt. Kita darab multiply with 1.1 is fixed. You cannot argue, you cannot change. This value is fixed, 1.1. Compulsory to multiply with 1.1 in order to get the allowable minimum window inverter voltage. Ambil kau. Boleh? 1.1. From 210 multiply with 1.1. This one for the case of minimum case. Okay. And then we are going to calculate it in the modules in the string. Okay, in the modules in the string. Okay. Kelakar lah saya pergi final kan. Okay, saya pergi nombor 3 ni. Okay. Ni. Finally, the minimum number of module in the string is calculated by dividing this figure by the minimum module voltage. Okay. N min module to minimum numbers of module in one string that connected to that inverter is equal to the Vmin inverter allow yang atas ni bahagi dengan Vmin MP effective. Vmin MP effective. What is that? Kita pusing, bawa saya patah balik ni ke atas. So ini minimum voltage, minimum module voltage is multiplied by the voltage drop expected across the DC cables. Okay. Yang ini pula datang dari mana? Datang daripada Vmin MP. Vmin MP datang dari mana? Datang daripada the previous calculation. Ni. Oops. Dia datang ni daripada sini. Datang ini datang ni lama pergi. Okay. Datang ni daripada yang tadi lah. Yang kita kira tadi tu. Sebab tu kita separate dulu, kita kira yang modul dulu. Okay, kita kena modul settlekan dulu 3 and then all the three calculations, all the three values, then after that we're going to proceed for the inverter part. So inverter part ni after we get the allowable window voltage tu, we need to calculate the minimum number of modules. Okay, that minimum number of modules require the values of the Vmin MP. Okay, Vmin MP. But there's another one. We call that a VDC drop. This is same as the yang PV inverter tu. Macam highway tu punya voltage drop lah. It's considered voltage drop. Like I told you, maximum allowable voltage drop for the PV system is 3%. based on the MS 1837 2018 standard regulation. So maximum 3%. So mean 3% mean 1 minus 3%, 0.97. Okay, macam tu. Okay, and then after that we are going to get the V mean MPP effective. Then yang ni yang kita akan masuk kat sini. Then kita boleh kira we can get the value of the minimum number of modules in one string. Boleh. Means that for this case of inverter ni, yang minimum 4 ni, so dia kena first daripada inverter punya voltage, minimum voltage yang minimum tu darab dengan 10% become 1.1. Then after that dia ada lagi discount, dia bagi ke discount lah, dia bagi lagi backup plan sebagai margin lain, darab lagi pula dengan voltage drop untuk mengelakkan any trouble happens in the future. Why? If the voltage is too minimum, what will happen to inverter? Inverter will not turn on. Okay. Output voltage of the modules, siapa yang design untuk PV ke apa benda ke, nak buat standalone ke, even sekarang ada dia punya range of input voltage, you must be in that range. If lower than that, inverter will not turn on. If the inverter will not turn on, nothing will happen. No energy generation, no energy transport, energy export, memang tak ada. Sebab memang inverter ni it's designed based on the minimum voltage. If don't achieve, if the input one doesn't meet the minimum number, so it will not turn on until even 30 years, will not turn on. So we have to make sure that even in the rainy season, even in the very cloudy season, the voltage still can support, so that the inverter will still on. Walaupun tu design ni sangat kritikal, walaupun dalam keadaan cloudy pun, even in the cloudy case, inverter still on, so that we can export the energy. Kita boleh dapatlah duit sikit daripada dia tak nyala habis kalau salah design. Okay, that's why this process is very critical. Boleh faham ke? Saya ada diagram, nanti saya tunjuk dalam bentuk diagram ni. Sekarang saya cuba tunjuk, I try to explain in one slide. Nanti saya buat ada diagram khas untuk lebih faham. Boleh ke?
Boleh, saya boleh.
Cakap boleh je. Cakap boleh, saya proceed. Aku tak nampak ni masalahnya. Okay. Saya proceed boleh Okay. Maximum number of modules in a string. Okay, maximum number of modules in a string, there's two cases lah here. Minimum number sama tadi kan, ada satu je. Maximum number ni kenapa ada two cases? Macam saya cakap tadi lah, kita ada dua value. Okay, VOC dan VMP. That's why we are going to have two values for the maximum number of modules in a string. Minimum number we only refer for the V min MP. Betul. Dan V min MP sajanya effect kat sini. Jadi datang ni. Ni saja. But for the case of maximum, we calculate same cases as the module 1. We have the maximum based on the open circuit voltage and maximum based on the ni kan, apa nama tu? Power point, MPP kan. So same lah like here. Okay. But there's different here. For the case of maximum, there's a different. What is the different? The margin. The margin is taken here is only, alamak, mana binatang ni, dia tak keluar, tolong. Sekejap Okay. 5% safety margin. Okay. 5% safety margin means what? 0.95. Not 1.05 Don't make mistake Sebab dia tadi kita lihat tadi berapa tadi nilai kita tengok ni? 420. Allah. Pergi sini. So dia ni 420. Just now 530 for the maximum inverter voltage. So 530 and 420. So from there we multiply with the 0.95, which is the value must be lesser than 530 Must be lesser than Vmax It must be lesser than Vmax. It cannot be more than that sebab tadi the range is given like this. Okay, let's say the space of some door, okay, like this. So this is the same as the range, the MPP voltage range. So we must be in the middle. Kita tak boleh lebih lah sini kan. So kita mesti dalam kecil sikit. Dia masuk asal boleh shoot dalam ni kan, betul? Kau faham tak aku cakap apa ni? Ni kan, dia boleh masuk tengah-tengah ni lah. Masuk tengah-tengah. Tak boleh keluar. Jadi masuk tengah-tengah. So masuk tengah-tengah ni means that kita kena kecilkan sikit. So untuk case maksimum ni, we reduce it 5% to become 0.95. Faham? Okay, maksudnya minimum tadi atas, minimum bawah, bawah kan, kita atas sikit, up. Yang atas kali ni kita turunkan sikit. So dia antara in the middle lah. So itu memang margin. Supaya nanti in case if the module are overperform, it will not exceed more than the highest rated. Kalau kita adjust ngam-ngam for 530 kan, or 420 maximum, tapi dia pergi 435 contohnya. So dia akan stop juga. Inverter tu memang kalau tak ada, if it not in that range, it will stop, automatically stop because the switching already there. Dia memang ada auto switch off. Itu dia punya safety protection kan. For the sake of safety purposes, then it already have the cut off one. So we must in the middle. If even though we have the modules overperform, it still can tolerate, still in the range of the voltage tadi tu. Ini sangat penting lah. And then how to calculate the maximum number module, kacang saja, yang ini from the inverter and this is from the module. Itu konsep ni yang besar bagi yang kecil. So inverter voltage bagi dengan modul voltage, senang cerita lah. Then you're going to get the values lah. Boleh? An array normally has several strings connected in parallel, and the input DC current will be the sum of the currents of all the strings connected to the inverter. Array normally has several strings connected in parallel, and the input DC current will be the sum of the currents of all the strings connected to the inverter. Okay, logik lah. String mesti ada banyak parallel, nama lagi PV array ataupun PV farm, solar farm kan, takkanlah satu panjang string kan, mesti dah banyak. So array. So dia ada banyak lah yang connect in parallel, betul? Connect in parallel. Okay. The short circuit current is used in this calculation because it is the largest current the module will produce. To calculate the maximum number of parallel strings of the array, then nak kira maximum number of parallel string of the array. Okay, macam mana nak kira n max parallel string? Yang boleh berdasarkan inverter tadi, kita ambil I max DC inverter. I max DC inverter. Okay, DC tu mean that input lah, input. I max DC inverter tu input voltage untuk modul tadi. Untuk inverter tadi. And then over F70 multiply with the ISC string. ISC string ni sama dengan ISC apa ni, ISC modul. Logik lah kan? ISC modul tu is the same with the ISC string because the modules are connected in series. For example, we have 5 modules connected in series. All current is the same. Okay, all current must be same. Cannot differ. Okay, everything is the same. What is the F safety? F safety is the safety factor. Okay, safety factor here. Ini memang dah fix segala. Range between 1.1 to 1.25. But actually it depends on the question lah. Kadang-kadang saya bagi 1.25 ke, kadang-kadang saya bagi 1.1 ke, sometimes I give you 1.0. But if the value is not given, just take the typical value. What is typical value? 1.1. Boleh. F safety equal to 1.1 is the typical value for the safety factor. Okay. If the given value is given, follow that. 1.25 ke, 1.2 ke, 1.1 ke, 1.15 ke for example, just follow that as it is. If not given, then you can assume 1.1. It's okay. Alright. So this for the case of the maximum parallel number of parallel strings of the array by using the inverter. That's why we need the I max DC inverter. Okay, I max DC inverter. So the input current from the inverter, the input current for the inverter that comes from the output current from the PV array. PV array. So PV array punya output current tu tak boleh lebih daripada rated ni. Contoh. Baru kita dapat berapa banyak parallel lah. Okay. Daripada sini kita boleh kira berapa parallel yang kita boleh masuk dalam ni. Supaya dia tak over limit the input current of the inverter. Nanti boleh meletup dan sebagainya kan. Sebab dia over current. Okay. Kita pergi example 4. Okay. Kita pergi example 4. Sebab ni. Okay. Boleh hang ni. Hang pula ni. Okay. Let's go for the example part. Please focus focus Based on given inverter and modules below, identify the best configuration of modules that should be installed. Assume the maximum numbers of module received is 35. Okay. Alright. Maximum number of module given is 35. Then we are given inverter and modules below. Okay lah, inverter ni ada beberapa jenis kat sini, tapi tak apa. Kita follow yang mana? 35 ke? Okay, tak kisah. Tapi mean that the inverter is given and the solar blue, the module is given. Okay, this is the example of the inverter pro news punya sheet. So, nampak ni MPP voltage range. So this is the value MPP voltage ni kita dah dapat dah 230 sampai 500 and the maximum input voltage is 600. Maximum input current for the place ni is 16. Okay, 16. For 35 lah, if 50 then 18.3 lah. Okay. Okay. Usually when we call the inverter, the rated power of the inverter, for in your opinion, which value that we will choose? Kalau kita nak sebut what is the inverter size? Okay, inverter tu berapa watt? How much is the watt for the inverter? Kalau pasal sini kita ada beberapa value tau. Kita sini rated. Okay, let's go through the 35 one 35 one. They give you the rated DC output in watts. 3,700 watt. Okay. What's next? They give you the rated AC output in watt. 3,500 watt. Maximum output power is the same, 3,500 watt. Okay. If I ask you, what is the rated power for this inverter 35? This inverter Fronius IG plus 35? What is the rated value for it? Boleh siapa jawab? Siapa lah? Siapa ada ni? Amirul. 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 Hello. Senyap je dah. Siapa lagi tahu tak nama siapa lah. Siapa saya nak petik nama lah. Tak ingat pula. T. Shan Wei. T. Shan Wei ke? Betul ke nama tu? Ke Li Shan Wei? Nama. Siapa? Shan Wei. Saya tahu ada depan. Sorry, nama depan tak ingat. Ada Shan Wei ada. Senyap. Salah sebut nama. Tanya Ivan lagi lah. Ivan.
Yes, sir.
If I ask you what is the rated power exact rated power for the Fronius IG plus 35. Berapa value dia? Saya ada bulat-bulat tu. Which one is the correct one?
Three 500.
Why? Sebab 35.
Don't know, sir.
Kenapa? Saya tanya orang lain. Siapa orang lain dah? Nama tak ada. Ada nama sedap lah. Satu screen kan. Saya tanya balik orang sama boleh tak? Boleh tak tanya orang sama? Kali saya jawab. Nafi saya jawab. Lagi yang nama dalam ni. Saya tanya Atika Nordin balik lah. Boleh Atika Nordin? Sorry. Ingat nama orang lain?
Ya, sir.
Apa rated power dia untuk yang 35 ni? Tadi Aivan jawab 3,500. But the reason, he don't know the reason. He doesn't know the reason.
Saya rasa sebab dia minimum kot.
Minimum apa?
Minimum volume.
Minimum
Value, sorry.
cara penilaian kau. Okay. Kita tanya Fatin lagi. Fatin Kristina. Sorry, tanya lagi.
Ya.
Orang lain. Siapa? Awak rasa yang mana satu betul?
Betul lah tu.
Yang mana? 3500. Sebab? Tak tahu sebab?
Tak tahu.
Tak tahu. Aduh. Okay, Fatin seorang lagi. Fatin Nadia. Nasib lah nama tu je saya ingat. Fatin Nadia nama. Fatin seorang lagi. Hello? Kedok? Nafis lagi lah, Nafis. Cepat Nafis.
3,500 je.
Kenapa 3,500
Sebab rated.
Rated? Atas tu pun rated juga. Rated DC output tu, atas tu rated juga tu. 3,700 tu.
Sebab saya tanya power, so dia ambil yang max output power kot.
Max output power. Max output lah. Max output power, gitu.
Rasanya macam tu. Tak tahu.
Okay, jap. The answer is 3,500 tu betul. Betul. Saya nak tahu reason dia apa kan. Okay. Saya nak tahu reason dia nampak macam tak jumpa kan. Okay, macam ni. When we ask the rated power of the inverter, we don't ask for the DC one. We are asking about the AC one. The size of inverter will be depend on the AC output. Rated AC output. Itulah yang dipanggil inverters tu size apa. I repeat. So you are going to look for the output. Output to AC. Output equal to AC. Input equal to DC. DC output. Tu daripada DC output daripada inverter lah. Daripada modul lah. Tapi DC, rated DC tu kan. Kita tak refer pada DC. Kita refer kepada rated AC output ataupun nominal power AC. Please look for the AC one. Rated AC. Tahu, rated AC. Kenapa? Rated AC, this rated AC lah yang akan dieksport. Maksimum tu, rated tu dieksport ke TNB ke, this is the size. DC, dia boleh pergi, for example, even there are 3,700, it can go until 4,500. If you look, there's some inverter. Some inverter tu dia boleh pergi jauh gila, sampai mungkin 5,000. But the output one is the one that our target. Kita nak fit kepada TNB contohnya, kita nak rated 3.5 kW. Input tu tak kisah berapa pun. Dia ada limit lah, ada limit. Dia mungkin sampai 5,000. Awak nampak macam loss lah, rugi. Tak, dia kita nak supply power tu dekat TNB kan. Contoh, saya bagi contoh. Solar farm in Pekan, the 30 megawatt one. 30 megawatt one is the AC. 30 megawatt AC. Okay, 500 megawatt is actually the AC. This is the size that are fed to the TMB, the size 50 megawatt. What about the DC? DC tu biasanya kalau you ada contract, you tengok contract tu. Contoh saya bagi contoh yang dekat yang in the solar farm Pekan tu, dekat area Mengarak Rompin tu kan. Iaitu 30 megawatt, but the DC one I think 41 something good, around that lah. So dia ada lebihan 11 megawatt satu kan, extra 11 megawatt, because the target that I told you, we must comply 30 megawatt size. That is the size that we want. Then we don't want any problem if we don't achieve the target. Ingat kan, remember the energy yield, then we must comply with that. Then we need to make sure that we have that, for example, berapa 100 200 megawatt hours per year. So we have to make sure. It doesn't mean that if we write 30 megawatt tu, DC kita 30 megawatt salah, tak boleh. Kalau DC kita 30 megawatt, then the AC also want to be 30 megawatt also, jam lah. Memang salah design lah. Kenapa? Like I told you, we have the factors kan, degradation factors, FMM, FSTEM, FDIRT, FDC drop, all the factors that degrades the things. That one, you need to consider. Even though the system, the megawatt of your module all is 30 megawatt, you akan takkan dapat lah, berdasarkan kalau hujan lagi jam. So target dia mesti oversize. DC tu mesti lebih lagi. Tapi the inverter tu must be comply the same target tadi lah. Even though they write 3500, tapi dia boleh pergi sampai 3700. Maksudnya modul tu pertama-tama susun 37, yang penting kita dapat rated tu. Kita nak regulate kan, make sure 35 megawatt. That's why we will look at the rated AC output. Remember rated AC output. Tengok pada output ataupun AC punya power. Okay. Same case dengan yang lain lah. Contoh kita ambil 65,000 kan. Yang ni memang size dia 6.5 kilowatt. Tapi dia boleh pergi sampai 6.8. Ini tak ekstrim sangat lah. Ada tu kalau tengok ada certain model tu memang boleh pergi mungkin sampai 7,000 or 8,000 lah. Certain tu macam tu. Okay. Boleh Fatin Kristina? Boleh?
Boleh, sir.
Okay. Nimala ada tak? Nimala? Okay, Nimala tak ada kot. Tak apa. Nafis boleh Nafis? Boleh Nafis?
Boleh sir, faham sir.
Okay. Boleh ke tak boleh, kena boleh ke? Tak kira. Okay. Okay. And then the right one. So tahu dah so kita tahu rated AC output kita. Lepas ni kalau orang sebut inverter size, tengok pada rated AC rated AC. Okay, rated AC dia. Okay, kat sini juga dia ada tulis maximum efficiency. Okay. Maximum efficiency ni ingat lagi kan, kalau kita guna masa bila, ingat tak yang masa kita kira ada pengiraan dalam energy yield? Tak nampak. Nampak tidur pasal macam ni. Tak boleh tulis tau. Kenapa macam ni macam ni. Okay, maximum efficiency ni yang kita ada inverter yang tu. Pengiraan energy ni tu ada efficiency for inverter. Kat sini ada. Kita ambil yang maximum efficiency. Jangan ambil euro, ambil yang maximum efficiency Okay. Alright. So yang the right side, okay, the right side one is the 235 watts of the module here. Okay. Ni saya bagi contoh peak power P max kan. Ini kira PMP lah ni PMP kata 1 plus minus 3%. What does it mean? Khalis. Sorry lah saya ingat nama-nama ni je, terpaksa tanya banyak kali. Khalis. Khalis tak ada? Tengah makan? Mirul Hafiz ke apa nama? Ada tak? Tak ada juga. Amirul Hafiz isi 19 apa? Tak ada. Apa lagi dalam ni? Aduh. Tanya orang sama ni. Banyak buang masa lah saya teka nama. Okey lah, beritahu je lah. Aku tanya, aku jawab Okay, plus minus 3% ni apa? Seorang jawab, seorang please.
Voltage drop.
Tolerance ke? Tolerance.
Okay, tolerance. Inilah yang tolerance, power tolerance, manufacturing tolerance. So this is the plus minus 3%, which kita akan guna nilainya minus 3 lah kan. Contohnya 100 watt, dia boleh pergi 97 sampai 103 watt. Maksudnya macam tu. So ini akan masuk dekat mana? Yang ni dekat FMM. Dia akan appear dekat FMM. Okay, FMM ni. Okay. So tolerance. Okay, tolerance. Lepas tu dia ada nilai VMP, IMP, IC, apa semua tu lah. Okay. Lepas tu ada temperature coefficient. Okay. Ni sebenarnya patut lama ni, tak tahu. Saya cepatkan. Okay. Ni solution dia. Soalan dia apa? Identify mana ni tak nampak. Mana ni? Okay. Identify the best configuration of modules. The best configuration module that should be installed. Okay? Best configuration modules should be installed. Okay? Maximum number of module given lah. Let's say 35 kat sini. Okay. For the solution. Okay, for the solution. Boleh mana-mana, boleh kira inverter dulu atau modul dulu, tapi dekat sini saya kira inverter sebab apa? Saya nak tunjuk lebih nampak jelas pun. Kenapa? Okey. Kita kira yang inverter tadi tu, tahu yang maximum apa dia tu and max minimum modul and minimum modul tu kan. Maksudnya kita kira yang apa nama tu V max window voltage minimum itu. Okey. Okay, part inverter what should we do? Okay, ini part inverter. So part modul tu saya separatekan. Modul tu saya letak terus lah. Modul dekat situ lah. Nanti susah nak differ kan. Patah balik. Then the third one tu total modules in series. Okay. So dekat sini saya terus assume lah. Kita ambil maximum cases which is the allowable voltage drop 3%. Okay, 3%. So tak payah kira lah. Ni kira 0.97. Okay, saya terus kira. VDC drop ni 0.97 because we assume based on the allowable given by the SEDA kan, maximum voltage drop 3%. So kita ambil situ. Okay. First kita pergi pada inverter. Bagi saya, when you answering your question, I advise you or I recommend you to do like this lah. I think this one is more understandable maybe. Okay. Mula-mula kita buat batang. Kita buat macam line. Okay, we do this kind of line. Okay. Lepas tu kena buat apa? Saya suka tiba dari situ kan. KRT tu tau. Kat mana ni? Kenapa dia pergi kat bawah? Jat. Okay. Ni. First of all, I put the maximum input voltage here is 600 volt. Sebab ikut inverter yang dalam ni datasheet ni. Lepas tu apa saya buat? Boleh agak kan? Next saya isi kat sini lah. Ni berapa? Apa nak isi sini? Ivan, sorry lah saya tanya lagi.
500.
500, betul. 500. Okay. Dan follow yang bawah sekali kita terus isi yang bawah ni pula kan. Okay, ni berapa? 230. Okay, 230. Okay, nampak jelas dah. Oh, ni masuk yang tadi saya cakap tu dalam ruang 500 to 230. Okay, what's next? Okay, kan kita kena kira allowable Vmax inverter, maximum inverter voltage allowable. Allowable tu saya cakap kalau untuk maximum tu kita ambil 5% margin, kita reduce 5% margin for the sake of safety. If overperform, the module overperform, it still can tolerate, it doesn't go until the 600 exact. At least dia ada plus minus kat situ kan. So at least kita tak adalah stop, rugilah kan. Dia overperform. Tapi sebab kita tak ambil proper margin, rugi dia stop. Pasal kita ambil 5%. So 5% from 600, 5% drop from the 600 become 570. Then same case for the next one, maximum untuk window inverter, inverter voltage minimum and maximum, which is the 500 volt. So that 95% for 500 volt give us 475 volt. Betul? And then for the case of minimum, as I explained before, we need to take 10% margin because the lowest one is quite critical. Even though we want to make sure, we want to have the proper plan backup if something happen. If the weather is totally cloud, it's totally raining, at least it still can provide us some very simple amount of energy, at least to be fed to the TMBR. It will not stop, it keeps exporting. Even the temperature, the weather is in the cloudy or the rainy season. So kita punya, that's our understanding lah. Kalau kita put the 230 volt, if the voltage cloud datang ni zap, dia turun bawah terus ada tu habis kan. Apa pun tak ada. Okay. Tapi at least kita ambil 10% margin tu, at least ada harapan lah. If sedikit walau secebis kan, ada energy yang di-feed ke TMB tadi lah. So dia 10% margin. So from there we get 253 volt. Okay, betul. Daripada bawah tu 253 volt. Okay, lepas tu we move. Okay, settle lah. Yang ni pun saya rasa ada beberapa markah. Ni boleh pergi 1, 2, 3, mungkin minimum 3, maximum 6 marks maybe, or 3 marks for all the things. Okay, then module. Module, remember we have 3 numbers that we need to calculate. Vmax OC, Vmax MP, and a Vmin MP. So VOC STC here, you get the value of the VOC. Okay, we get the value of gamma VOC, and we have the STC minimum. The STC yang tahu ni 20, yang ni 25, and this is the VOC is given here. Temperature battery, okay, minus 0.35%. Okay, percent, then we get the VOC one is the 36.9 volt. Okay, then keyword. Okay, remember minus 0.35 to over 100 because percentage. Don't forget. Okay, don't forget. Then you kira dapat 37.5458. Remember 4 decimals. Okay, 4 decimals. 37.5458 volt. Okay, that is for the case of Vmax OC. Clearly here boleh nampak kan, ini memang lebih besar daripada VOC STC. Vmax mesti, kalau you punya value rendah lagi daripada tu, so silap tu. You salah dekat the symbol minus, the minus symbol, you make mistake at that place. Okay, make sure don't make mistake. And then next is Vmax MP, and then you gantilah dengan VMP this time. Okay, this time VMP is not given. What should we do? And what should we do? Sekali lagi Atikah.
Ya.
VMP
Yes,
tak bagi kan VMP?
Tak.
Dia nak buat apa?
Guna PMP.
Guna PMP lah. Kita bagi jawapan dah saja je.
Oh, okay.
Then keep it okay. VMP STC, then you go to PMP tu dia bagi kat sini kan, minus 0.44%. So masuk nilai, then tara dapat. Okay, yang ni again yang ni pun mesti lebih besar daripada Vmax MP. Okay, dia mesti lebih besar lah. Logiknya dia akan lebih besar sebab dia positif, dia akan tambah. Sebab 20 minus 25 kan, dia akan dapat minus positif. Okay, next is the Vmin MP. Same case, not given, so use the gamma PMP, and then you kira gedebak-gedebu, you dapatlah 22.776, which is significantly clearly here lesser than the VMP STC. Okay, sorry, ini VMP STC. Okay, then total modules in series. Okay, terus kira and max OC. max OC modul, open scalable modul. So apa dia? Dia ni logik lah. Ni inverter punya part bagi dengan Vmax OC and the middle one. Okay. So bagi 570 over 37.5458, then you get 15. Oh, tak ada point sini, sorry, tertinggal. 15.1814 and it becomes 15. It becomes 15. Okay, nanti tu, tengoklah saya belakang. Okay. Next, and max MP block, So samalah, kita ambil yang the middle one, 475 over 29.8424. Then you get again 15.9169. Para dibulat 15 kan. And then focus on the admin module. So admin module, remember you need to add up the VDC drop. Okay, mana dapat ni? Dapat daripada sini. Okay, 0.97. Then we take the value of 253 volt over 22.776 over 0.97. Then you get 11.4517, which is this time 12 pula. Jadi 12 pula. Okay. Tengok max, round down. Minimum, round up. Okay, itu dia. Itulah, sama macam sebelum ni kita kira maximum number of modules that can be installed in the rooftop. Maximum number, kalau kita letak lebih, dia akan terkeluar. That's why kita round down. Sama juga, based on the budget, maximum number of module that we can buy with this amount of money. Again, we must round down. Sebab kalau you round up, you kena tambah duit sendiri. But for the energy yield, minimum number of modules, sebab we need to comply with the minimum energy yield, kena achieve. Kalau tak cukup, tak boleh. That's why kita round up. Okay, sama case dekat sini. Maximum round down, minimum round up. So the value will become from 12 to 15. Mean for both cases 15 and 15. So the between 12 to 14, 12 to 15 je lah. So maximum numbers, total number of string, maximum numbers tu boleh 15, minimum numbers tu 12. So in one string you can fit up the modules between 12 to 15. Okay, 12 to 15. Boleh ke maksudnya? Faham tak maksudnya? Ya, tu saya habiskan ni. Boleh faham tak? Minimum number tu 12, dia sampai 15. So antara 12 sampai 15 lah modules tu dalam satu string.
Faham, sir.
Okay. Then kita proceed pada total modules in parallel. Bunyi equation tadi tu maximum number parallel atau ingat ada maximum expectation jadi round down ke round up?
Round up.
Sudah.
Round down.
Round down. Maximum round down, minimum round up. Boleh? So ni IC string sama dengan IC STC. Lepas tu yang ni sebab kita pilih 70 lah. Kita pilih modul 70 tu. So dekat sini lah. Dia ada maximum input current, nampak ni? Wah, okay. Ni. Maximum input current ni daripada modul tu masuk. So input of the input current for the inverter. So it comes from the output current from the modules. So 39.7, then 1.1 is the safety factor that I told you. If value is not given, you take 1.1 for the safety factor. Ni. Dan ini from the modules. Then awak akan dapat 3.1213 which is the 3. Bukan 3 lah, kalau maksimum tadi kita round down kan ni. Ingat maksimum kita round down kan ni. So dekat sini, so therefore possible number of modules in series first 12, 13, 14, 15. Okay, 12, 13, 14, 15. And then parallel number sebab maximum is 3. So mungkin 0, 1 ni and 3. Okay, sound. Okay. So mungkin 3, 4 ni lah. 0 termasuk sekali lah. Tapi biasanya 0 tak lah. Okay. So dia ada satu lagi term kita panggil sebagai ratio. Nanti saya kaitkan dengan benda ni. Okay, kaitkan dengan benda ni lah. So ratio tu P nominal inverter over N series over N parallel over P mod STC. Okay, ini datang dari mana? Dia panggil ratio ni tujuan dia apa tau? Kita nak pilih the best configuration sebenarnya antara modules tu. Okay, so dia say sini ingat rated AC nominal. Nominal untuk inverter ni nominal ni. Ni yang kita dapat dari sini. Ni dia. Okay. And then N series and parallel 235. Oh, mana pula ni? Terlalu lah. Okay. Ini contoh table saya buat. Okay, saya buat satu table. So 14, 13, 12, 11, 15, 14 dan 13 contohnya. So kita nak cari the best configuration ni. Maksudnya kita panggil sebagai the best configuration. The given module 35 for example. And then 30. Okay. Saya list up lah. Macam mana saya list up dia ni? Sebenarnya benda nanti tak buat pun tak apa. Tapi tak apa, saya tunjuk benda ni sebab kita nak tengok best configuration. Ingat, maximum modul yang kita berikan adalah 35. Okay, 35. So kita sebenarnya nak lebih 35 lah. Kita nak ke arah gunakan semua modul yang ada lah. Okay, guna sebab kita we are given 35 modules. We try to do the 35 one. Okay, 35 one Okay, 35 one. Okay. So the ideal value sekarang ni, bila saya buat, so saya start dengan mana ni? 345 lah. 2 dulu, lepas tu 3. Okay. Okay. Lepas tu sekarang kita punya kan di kalangan 12 sampai 15. And then yang ni sebenarnya, okay, yang ni saya letak, boleh je letak 12 sebab rasa macam buang masa. Tapi ini saya just tunjuk kalau dalam exam, kalau dalam assignment ataupun dalam final exam tu tak payah buat semua pun. You dapat 1-2 line cukup dah bagi saya, tak payah banyak. Okay, as soon yang penting sampai target dia. Okay. Yang ni kita daripada 13, 14, 15, 16 dah 2 dia jadi 32 kan. Daripada 2, 32. Tapi 16 tak boleh kan. Sebab maksimum kita tadi kita dah cram dekat 15. So maksimum macam mana pun 15, minimum 12. Yang ni abaikan boleh. Ini abaikan tak apa sebab kita punya minimum numbers, minimum number of series tu sebenarnya 12 kan. Dia atas 12 dengan 15 lah. So ini kira-kira dibuat macam ni 2, lepas tu 15, 2, 30, dah 2 je. Dah 2, lepas tu ini 12, 2, 3, 3, 39, 14 dah 3, 42 dan sebagainya. And then ratio ni dikira daripada ni. So ini adalah total number ni lah. Ni daripada dicedok dari sini lah number ni. Okay. And then 235 ni sebab dia rated voltage. Dan ini adalah inverter. Okay. Lepas tu the ideal value maksudnya the best configuration here to get that value, ideal value between 0.9 to 0.9 to 10, 0.9 to 1. Okay, 0.9 to 1. So dekat sini ideal value ni ada 2 lah sini. So kita ada 28 dan 30. Kita ambil yang maksimum lah, semaksimum mungkin. Modul tu kita nak publish kan, kita nak maksimum kan. So kita cari yang maksimum. 30 lebih besar daripada 28. So kita ambil 30 dan kita masih lagi range 0.9 to 1. So ini adalah the best configuration. Okay, so best configuration here is 15 series multiplied with 2 parallel. Even though we are given 35, tapi this is the best configuration lah. based on the ideal value ratio tu dia nak 0.9 to 10. Kenapa to 1? Kenapa? Apa maksud ini? Apa maksud yang modul ni? 0.9 ni apa maksud dia? Kalau value dia besar, okey. Maksud saya apa maksud value tu besar atau kecil Value tu besar atau kecil? Okey. 0.7 tu apa maksud dia? 0.7 tu maksudnya kalau tengok daripada ratio, maksudnya bawah ni lebih besar daripada atas, betul tak? Bawah ni lebih besar daripada atas lah. Means that inverter tu too small. Inverter tu terlalu kecil. Okay, inverter tu terlalu kecil. Kalau 0.7 tadi tu. Kalau 1 tu memang that's the best that we can lah. Kita dapat 6,500 atas, 6,500 terbaik. Itu memang fully. Kita dapat total up. Mungkin semua modul tu kita gunakan. Itu the best suit lah maksudnya. Tapi kalau what happen if the value is 1 point something? 1 point something, for example, yang macam ni kan. Yang ni contohnya, saya awak dapat 1.3. Apa maksud 1.3? 1.3 tu maksudnya apa? Apa maksud 1.3? Lagi sekali. Siapa? Aku tahu. Lagi sekali ni. Nafis. Last. Ending. Hari ni Nafis 3-4 kali katanya.
Yes, sir.
Kalau saya cakap ratio tu 1.3 kan, apa maksud dia? Kita nak cerita apa ni kat sini? Tadi saya sebut, kalau nilai dia 0.7, itu maksudnya bahagian bawah lebih besar kan?
Ya.
Okey, bahagian bawah besar maksudnya inverter tu terlalu kecil. So dia rugi lah, satu kerugian, undersizing lah, satu kerugian lah. Sebab kita patutnya dapat supply yang lebih besar. Tapi because we are using the small inverter, so we cannot maximize our output to the TMB. Tapi kalau nilai dia besar maksudnya apa? 1.3 tu.
Maksudnya untung lah, sir.
Untung? Apa yang untung? Tak, between 0.9 to 1 tu ideal, tu terbaik. Maksudnya inverter tu kita just nice lah, kita pilih just nice. Kalau nilai dia besar, maksudnya inverter yang kita pilih tu terlalu besar. Okay? Bila guna inverter terlalu besar tu, cost dia lebih tinggi. So dia jadi agak loss kat situ. Dia oversizing lah, macam oversizing. Okay? Jadi sepatutnya kita kena design tu just in the value of 0.9 to 10. Kalau nilai dia lebih daripada 1 tu tak bagus lah. Maksudnya inverter terlalu besar. Mungkin you patut guna inverter yang lebih kecil. Contoh tadi kita ada inverter 50 kan. So kita akan guna inverter 50 lah. Tu maksud dia. Kalau ratio tu besar. Inverter
Okay, saya faham.
Kau beli yang besar, pada rumah rebat dia. Beli sampai level solar farm. Rumah pakai rebat dia. Kan tak balai tu. Sama kes lah macam rumah kita level istana kan. Tapi beli inverter size yang memang untuk rumah flat for example. Rumah teres. Tak sesuai lah. Dia tak cukup lah. Dia tak dapat nak supply.